We can show what they did. Oh, thank you. So obviously we had not much time on that. We will be talking about those things today, so that's okay. But do you have any questions in terms of the things that we did until yesterday? Have you made some progress in understanding those that, okay, I tried to, because your data set you had the data set, you could actually just simply go through some of the commands, whether you're following it or you're not following. Where are you in that sense? Yes. Okay. So you didn't know how to run the Postman test. Okay. Can you show your log file? Okay. I'll come to you. Okay. Anybody else try? So what happens is when you run a model, in order to test the Postman test, you are running, let's say, two models. You need to do a comparison that, okay, whether the results based on this model are similar or different from the results based on another model. Okay. At a point in time in Stata, there will be only one set of results in the memory. So let's say you ran the first one, the result is there, and then you ran the second one, so the first one is gone, and only the second one is there. Okay? And if you try to do the comparison, there's nothing to compare. That will say, so there is nothing to compare. So what we need to do is, so when you run the first one, then you have to ask this data to store the results. Okay? So you give a model name, the results, that, okay, these results needs to be stored. So for that, I was using a part of the commands which is ESTO, okay, ESTSTO, okay, which was the short for the estimates store, okay, and then a name, you can give whatever name you want to give to that set of the results. So what it will do, it will store that one, and then you run the second one and ask this again, store this result with this name. And then you can run the Postman, say that, okay, compare this with this. Now Stata has both the pieces, and it knows what you are asking it to do. You are asking it to compare two things, and both of those pieces it has got. Okay? So let me just go back and see. So, for example, we are running, let's say, a fixed effect model. Okay? And I'm not sure if you followed the syntax, all of it, okay? Because there must be something. If you try, it will give you a warning because there was something missing in the version that you have. Okay? So if you look at it, there are two lines in there. Okay? The first line is asking it to run the model, what the model is, and describing what kind of we're asking. Okay? So the model is, you are asking, okay, the xtreg, so you will using the panel data set, okay, dependent variable, the list of independent variables, and we had some additional predictor variables on top of the list that we had originally. We added some more on top of that. Okay? And then we are asking I is the unit. Okay? So in a panel data set, you have two things. Okay, there is the entity and then time. Okay, so I is just the identifier, which is for the firm, which was the ID, identifying each of those. Okay, and the last one is the FE is telling them that, okay, I want you to run the fixed effect. This telling Stata that, okay, please run the fixed effect model. If you just did that much, there is an output that will pop up here. Okay, but if you didn't do the second part, okay, there is a second line there too. Okay, and if you tried that, it might have given you a warning. Okay, that something is not there. Okay, yes, that's the point. Because it will tell you that there is, this is, I'm looking for this, you are giving me a command that I don't understand. Okay, so you need to look for it. Okay, so there is a way you can go to the command, okay, and you can ask that search that command that you are giving, okay, STO. Okay, so this is the one that we are asking. Okay, you just say, okay, search for this from the command window, find that. Okay. Now, when you do this, now it is going to search, and it will now probably show some probable leakages. Okay. Because there were some user-written packages that this was one part of that a bigger package. So there is a package that does more things, and this one is one small thing that it does, and it's part of a suite of commands, and this is one of those things that it does, which is just stored. The estimates are stored, and the second part here, this is just a name that you can give any name, whatever name you want to give. So I just gave a name so that I can understand what this name is. So I know from the name itself that it's a panel regression, and it's a fixed effect. So this is the name for the storing this result. Okay, so you can run many other models, and you can actually restore that. Okay, so there is another command, estimates restore. Okay, so when you say estimates restore, it will now bring it back the model you are asking, the estimates you are asking that, okay, I want to see the results that I did maybe an hour ago. After that, I did many things. Okay, but because you have stored it with a name, so now you say that, okay, estimates restore the name, then it's going to bring back. It knows what you are asking. Okay, so any command or anything is just that the language we are telling, the other person needs to be familiar with the language. So because this piece was missing, it was not understanding. So what is happening is, it's a new version of Stata. You can see that it's Stata 16. Okay, so Stata 16 has just and just like your phone. Okay, so your phone have apps. Okay, and every person's phone might be very different, even though you might be using the same company and same model, but you have different apps, and everyone's apps are different, and it's customized. Okay? So that happens with also the R or any of these things, because you write some your own, you actually install from the other users. So your personal library is very customized to your kind of applications, the way you are using. And this is a standard, okay, off the shelf, just so there is no customization done, there is no addition or anything has been done. So this is part, it's an old one, but still useful. Okay, so when you do this, so you can try this. Okay, you can, if you are doing it, you can look for the East store. Okay, search for it, and then you have to click on that, and I think it's package 85_2. Okay, so there are two versions of that. So every package has a date. Okay, so you can look at, okay, which date there was an older version of that, and then there is a newer version of the same package, and you can install the newer version, and it will install. Once you install it, now it's part of your library. Right? So once you do that, then it just kind of helps you to kind of do the Hostman part. Okay, so Hostman part was obviously I didn't talk about that, but I was expecting people to do the graph for the plotting the results. right? Because, and I wanted you to actually make some effort to try to learn, okay? Because at the end of the day, you can only learn maybe few things, okay? It's just an introduction, okay? I know some basic stuff. After that, the things that you need to do, there are a lot of things that you need to know that you don't know. And if you have not developed a habit of how to teach yourself, there is no way you can finish that, because every task, every project has some unique requirements, okay? There is something that you need to do. There is no a ready-made solution for that. So you have to struggle. That's part of the process, okay? That I want something very specific that needs to be done. At times you may not really fully understand what exactly you want, okay? So it is also a process of learning to understand, okay, what is my problem and what kind of thing I want to be done, okay? So you will see like there is a Stata list also. So the Stata list is just like a community of Stata users, and you will see there are a lot of noise users, and there are also experienced users. It's a mix of those community. That's how community forms, that people are asking questions and there are people who are responding to those questions. And those people are very sort of particular about the protocol. Okay? The protocol they follow, and if anybody breaches those protocols, they kind of really come hard at people. Okay? So some of the protocols is that if the same problem has been asked before, you have searched for that, okay? That the solution might be there. So you have to, should not be that, okay, it's a community and I just go and ask questions without making an effort, okay? That whether somebody else has asked the same question. Because rarely we get a problem that is so unique that nobody ever faced that problem, okay? So the chances are that somebody else also faced the problem. For example, let's say you face this problem, it's giving a missing command, okay? If you do a Google search, probably you will find that somebody tried to do the same thing, okay? And Stata is giving an error message, code, okay? That this is, so every error has a code so that people, they know that what kind of problem it is. So they have categorized different kinds of problem. So this problem will, the error code will tell that what is the issue. The issue is that the Stata does not have the command it needed, okay? Yes.
And when I will do I dot ID, it will create dummies for complete also?
Yes. 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 Any moment you take a variable and you put C dot, so there's the Stata's way of telling Stata that it's a continuous variable. If you put an I is a categorical variable, okay? So it could be dichotomous. So if it's a dichotomous, there will be only two levels, okay? If it has more levels, it's still a categorical variable, but it will have more categories. So essentially, I is for indicator variable. So that's how the C is for continuous, I is for indicator, and it could be a dichotomous, it could be more levels, say categorical variables, and it will create the dummy variables. You can create your own dummies also. There is a way to create a dummy variable, but that just increases the memory that is be consumed by the Stata, because you are creating variables that Stata does not necessarily need to be created. Okay? So if you create your own dummy variables, now it will be in the memory. Okay? And if you are handling big data sets, then it's going to consume a lot more space. So it is just for conservation of space, that it doesn't consume the Stata space. Okay? So that's the first part. Okay? You run this part, estimates store with a name. Name could be anyone. Okay? For us here, we gave the name XT. Now this is this one, and then okay, we have the other one. The only change here is to tell, let's say, random effect model. So that's the only difference there. And the name has to be different. Okay? So it's a new model. We just are saving it with a random effect, just a notation that it's a random effect model. So now the data has the two models that it needs to compare for the Postman test. Okay? It has the fixed effect model stored and the random effect model stored. Okay? Now you are ready to give the command to say that, okay, I want to now conduct the Postman test. So let's do that. So it's simple. Okay, you can right now forget about the some additional options, but all you are doing is Postman is just the Postman test and the name of the two models. Okay, the fixed effect model and the random effect model. It's going to compare those two, and something like this will show up. Okay, so now something has showing up on your screen. The other issue is now what does it mean? Okay, so I'm seeing this. I ran the model 1. I did the 2. I ran the Postman command, and there is an output in front of me now. So what does it tell me? Okay, because we are looking for, okay, which one I should use. My question is, should I use the fixed effect or should I use the random effect model? Okay, that's the basic problem that we are trying to solve using this, and we are running this test, and now it has given me an output. Okay, and I'm figuring it out. Okay, what is it telling me? Is it telling me to use this or that? Okay, who is going to tell me what is it telling you? I'm asking you, what are you going to decide? Okay. So it is, the number is, output is there. I just copy and pasted can you see the output from there? Okay. Yeah. Can you read it? What is there? Okay. Okay. So yeah. So okay. So what does it mean? Okay. Okay, very nice. And then what should we do? No, the fixed effect model. Okay. So if the null hypothesis is rejected, that there is no significant difference, then the answer is that. So very nice. Okay. Thank you. You know what to actually, how to read it. Okay. Because that's the next part. Okay. That you run this. You got the result, but still it's not telling me the direct answer, okay? Because my answer is, okay, tell me which one I should use. Okay? So at the end of it, like all those numbers are there. I can see what's the null hypothesis. I can see that it is significant, but I probably still don't understand what exactly it is asking me to do. Tell me, Jack. Okay? Hopefully they will one day, they'll also program it and then say, okay, go do this because you got. I mean, that's one more step. There's nothing a lot more to think about it, because it's the null hypothesis has been rejected, so there is no systematic difference. So the default is that, okay, you should be using the fixed effect model. Okay, so that's from the Postman perspective. Okay, now I also mentioned that it's not just the kind of like the empirical issue, it's also a theoretical issue, that okay, which model should be used is not only what this Postman test is telling you, but what is your theoretical question you are asking? Because I mentioned to you that given the kind of question you are asking, you may have a different types of hypotheses. Okay, so there are hypotheses written in a way. I have seen many people doing this mistake, that they have stated a hypothesis, okay, without realizing that they have stated a hypothesis that requires a particular one of these two, okay, not driven by Postman, but based on what they are trying to examine, what they are trying to test, because you're trying to test your hypothesis, right? That this is the hypothesis and I want to empirically examine that hypothesis. Okay? If you are doing Hawking, okay, that's another question, but if you are doing based on the hypothesis that you have, it is telling you what test you need, because that's what is your hypothesis. Okay? But we need to understand, how would we know whether my hypothesis is telling me to use a fixed effect, or my hypothesis is telling me that I should be using a random effect model. Which one? How would you know that? Because that's an important point, okay? Because you can do all of this, but you have stated way before, okay? This is my hypothesis. If this happens, this is likely to happen. You have already done that, okay? And all these horsemen and all that will come later, okay? Data description, method, all of that will come subsequent to that. But that decision you already made, that what exactly you want to test. So any thought on that? That how would you decide that which one I should use based on my theoretical question? That what question I am asking. I'm right now, so there are some assumptions we kind of talked about already in the previous slide, okay? Some basics, but I'm thinking about just purely from the theory perspective, okay? I'm not looking at some of the assumptions of these models and all that. I'm just thinking theoretically, okay? That given my theoretical question, that this is the hypothesis I want to test. So if that's the hypothesis I am testing, there is a, by default, there is a test that you should be doing in order to test that hypothesis. Unless you modify the hypothesis given the test you have, okay? That's harking, okay? Because now you have a test and you have the result, now you're changing your hypothesis because, oh, I did this one, so I need to do different. But if you're following the positivistic approach, then you have already stated your hypothesis, okay? You already have a question in mind based on the literature review and all of that. You've already stated a hypothesis. My point, I'm just trying to drive it here because it's not about you when you're still learning, okay? I've seen very, very experienced people, very, very well published people not knowing the difference between these two, okay? Because how to decide, how to understand. The thing that it's not coming from there, but no, it's coming from there. It is the question that is telling you. But I'm asking anybody here, how would you know that? Just a guess, okay? What kind of different questions will point you to do one kind of test versus the other kind of test? You're not looking at the theory when you're looking at the correlation. You're already in the data part, okay? So I'm looking at just the theory part, okay? So I'm looking at the front part of your paper where you have a research question, you did the literature review, you have proposed hypothesis, okay? Exactly. So if I am asking a question that how, so let's say you are studying something, okay? Let's say you are looking at policy in schools, okay? Or some things that schools are doing in their schools, some policies or some practices or some incentives they are offering over a different period of time, which is something that is changing within the school, okay? And your hypothesis is that if these things the schools do, we expect the students' performance or outcome, something to happen, okay? So now what you are looking at changes within the school, okay? So school is the unit of analysis that you are looking at, and your interest is that what this school, a given school, has done during the last 5 years, 10 years, whatever, okay? How that has changed. I'm looking at if, so that some schools may be good schools, some could be bad schools. So I'm not comparing good versus bad schools, okay? So even the good schools, wherever they are, what they have done, okay? Whether their improvement or change is leading to a change in the outcome or not. Or there were some bad schools, okay, fine, they're bad, okay? But if they did that, whether they saw some improvement or not, or there is a difference between the good schools benefiting or not benefiting, the bad ones benefiting. So this is a within change versus between school change, okay? So if your thing was that, okay, the richer schools will have this kind of impact on the student performance or the outlook of the students, okay, versus the poorer school. So now your interest is you're hypothesizing that the between differences in the schools. Okay? If you're looking at, let's say, companies, okay? If you're looking at, okay, the larger companies will have this kind of relationship. Okay? So that's a random effect hypothesis. But if I say the same kind of thing, but in a fixed effect hypothesis, as firms grow larger, this is going to happen. You see the difference between those two? I'm looking at the size, okay? Firm size. That bigger, as the firms become bigger, that's a fixed effect. If I say the larger the firm, the more or less will be something, okay? That's a random effect hypothesis. Do you follow the difference between these two? So you put it very nicely, okay? So things, if your variable of interest, the theory that you are testing, is not changing over time, okay? It's not it's fixed within each individual, okay? There are certain characteristics of the people, okay? Let's say you are looking the effect of race or caste or something, okay? Which is the person is born with that, okay? It's not going to change no matter how many years you are looking at. So you cannot apply fixed effect model. Okay, so your theoretical question is that, okay, people of this caste or this race or this one, if they are exposed to something, a government policy or whatever you throw in there, okay, will have this kind of behavior or this kind of outcome performance. Okay, so now this, forget about Hausman, what the Hausman is going to tell. You should know that this is a question that requires random effect model. Okay, there's no way you can actually do it with a fixed. So any variable in the fixed effect model, when you run it, okay, which does not change within the firm, it is dropped from the model, okay, because there is no within difference. It has remained constant over the entire period. Okay, so when you run a fixed effect model, any characteristics that remains constant over the entire observation period, you cannot see any within effect difference. Okay, so you cannot test the effect of those are essentially dropped from the model because it is not changing, it remains constant. Okay, I hope you follow that part. Okay, and you also follow now that how to do the Hausman and how to interpret that what it is telling and how we should follow based on that. So there are two sides of it. Okay, you need to be, so that's why it's a problem when I come across people that say, oh, I'm a theory person, okay, or I am an empiricist, I do the data side, okay, I don't understand the theory side. No, you can't be a good researcher if you actually don't know the both. Okay, and it's also even from the, like within the empirics, if you don't know the program and the econometrics, you can't be a good researcher. Okay, if you just know one, not the other, there are a lot of challenges that you won't be able to solve. You'll be stuck. You know the big part of it, but you cannot implement, you cannot execute. Okay, because at the end of the day, it requires a successful execution, understanding and being able to implement and being able to do both. So it requires to understand the problem both from the theory side as well as from the empirical side, that, okay, given the now, once I have the information, how I want to interpret that. Okay. Now, here we had in the model, so I was looking at the effect of sales and just plotting that, okay, how the effect in that model, okay, because the sales was appearing. So in its data, we write this thing. So if you're writing, let's say, an interaction, let's say there is a continuous variable, so I'm writing C in front of that, and I'm putting a pound sign, okay, and let's say I'm putting another one, a variable. So it's looking at the interaction between these two. Okay, I have a pattern of a variable. So it's a kind of a funny way of saying that, but it is essentially the same thing, interaction with itself. Okay? So it is now telling, you will find funny, but that's what this data is doing. Okay? So I'm looking at a square term. If I'm looking at the cubic term, I'll do it 3 times, okay, as opposed to generating a new variable that is a squared of this one. Okay? That can be done, but there are complications that will bother you later on if you do that. Okay? But that's also possible to do it. Okay? So now it had the squared term, and in the which we had drawn, so the linear term was positive, the square term was negative, both negative, right? So it's kind of the effect you are seeing that, okay, how the performance is impacted as sales is increasing, and we are sort of seeing that it's a curvilinear kind of relationship with this. Okay? So we haven't done the interaction, but just looking at the effect of one variable, that how that variable changes, and we are looking at the firm sales, right? The scale. So I'm sort of running. If you look at what is given in the command, so we are giving it, asking it, okay, margin is the command to do the calculation that is needed to compute these values, and then telling it, okay, at put a comma, sales, okay, and now I'm telling it the range, okay, the range is 0.08 to maximum probably 7.5. Okay, so usually I like to see the effect in the whole range of the data that in my sample. Okay, so I'm looking at pretty much the minimum to the maximum range, and in between that you are seeing, so there is another one showing like 0.7, which is the increment. Okay, so it will start from the 0.08, and it will look at the sales value at the increment of 0.7. Okay, until it goes to 7.5. Or it may not be, the 7.5 may not be divisible by that, so it will go close to the variable that will be before. It cannot cross the 7.5 because I put the maximum there. So it will go with the increment of that, and it is computing the prediction. So what's the value of y, which is the predicted variable, and then simply it will generate, in order to generate the graph, there is a margins plot. Okay? So if you just do the first part, then you will see all the values. Okay? So the values will be from 0.08 to 7.08 at the 0.7 increment. Compute how many of those observations will be. For each of those sales observation, what will be the value of y, which is the outcome variable here. And I am also telling it at means. Okay? So at means is, we are taking the other variables that were in the model and asking this data that, okay, take the average value of those other variables. Okay? Because we have to sort of hold them constant. In a linear model, this is not a big deal, but in a nonlinear model, the values of those other variables are very, very important part, because they appear in a multiplicative form. Okay? So in any time you change the value of those variables, the effect is going to change, not because the relationship has changed, because it is being multiplied with something that it's outside your model, but the value is changing. So you're looking at a low level or a different level, whatever level you give them, it's being multiplied with that value. So as that changes, the effect y will still change. Okay? So that's why that choice is very important when it comes to the non-linear models. Okay? Now I'm doing it, and I'm looking at the average marginal effect. Okay? So the average marginal effect is essentially, you can look at the slope. Okay? So dy by dx. Okay? Like you compute the slope, it's an incremental change at every point, that how the slope will changing. Right? So it's kind of pretty much at a similar kind of pace. It is coming down. So it is looking at each value, that how fast it is changing. Okay? And you can see that it is declining, and so early on the value is more. Okay? So it is giving you that at each point what happens if the sales value changes slightly. Okay? So slope it's dy by dx in the tangent at those curve. Okay, so the previous one was given the curve. If you compute the slope at any given point in time, that's the value it's being looking at, which is usually economists like to know the average marginal factor. Okay, what's the marginal effect? Because they are looking at, okay, where I am, I need to know what's the marginal benefit I'm going to get based on where I am, as opposed to what's the average effect. Okay, so that's why they are more interested in knowing the marginal effect for policy perspective or any other beneficiary perspective. Okay, now, so we did all of this. Okay, and every time I ran these models, I gave the same command, est.sto, which is estimate store, and their names were given. Okay, so we ran the first one was, so we were using the same data set. Okay, you can see we were the same data set. In the beginning, we didn't treat it as a panel data set. Okay, we ignored the panel structure. We treated it as like a pooled sample and ignoring any like a group structure in the data. So we ran it as a we ran it as a regress, and then we had a clustered. So there is a you can recognize the group structure with the regress command. Okay, and you are asking that, okay, cluster the standard errors based on the form ID. So I'm telling the regress. Okay, some people think that it comes closer to the panel structure because now I'm adjusting the standard errors based on the group structure. So I'm telling the data that there is a group structure. So these observations are coming, they belong to the same company. So please adjust the standard errors based on recognizing the group structure without setting a panel structure. Okay? So that's the second one, which is CLS was the cluster. So all I'm going to do here, it was essentially at the end, you write like a VCE and within the bracket cluster, and then the ID of the cluster variable, where it was the form ID, which we're using just the ID. Okay, so I will be writing VCE within bracket cluster space ID. Okay, so what it is doing is it is going to adjust the standard errors, and it is doing it by recognizing that these observations that are coming from the same ID, they belong to one entity, the same entity. So it's going to adjust the standard errors. Right? Now, and then we did two of those, the random effect model and fixed effect model. Now, what I'm doing here is I'm asking Stata to bring all of those estimates and put it at the same place so that I can see how similar or how different they are. Okay? Let's say, do those choices matter? Okay? That's what we're trying to understand by doing this. Okay? Because I can run any of those models. Okay? I could have, and things are sort of significant in all of those. Okay? Pretty much all variables are significant in all the models, more or less. Okay? If you see that. Now the question is, which one we should choose? How would we do that? Can you tell me? Okay. Which one would you pick? Let's put it this way. Which one will you pick if you have to do that? So I have all the results right now here, okay? And you have seen the data set, it's with you, okay? And we ran all of these. Now we're just putting and bringing them, all of them together at the same place. And now I'm asking you, okay, pick your winner, okay? Which will you consider is the winner among this race? So there are 4 models sort of competing against each other, and you are the judge, and you have to decide the winner. Okay, which will you pick? Okay, so I heard one answer, random effect model. Okay, any other? You can see the numbers there. So in the second one, we are telling these data that group adjust the standard errors based on the group structure, but it's not set as a panel data set. In the last two, we are specifically treating as a panel structure and running the panel command, the xtreg and the re and the x. Just simple regression. In the second one, we modify not the panel, but we are just adjusting the standard errors. So you can see that it's sort of people think that it's doing, but it doesn't do exactly that. But it is within the same regress command. Okay, so the command does not change. So in the first one, we are just simply doing regress. Okay, let's put dv. In the second one, we are just IV, and now I am giving an option here to adjust the standard errors, and here I am telling it cluster ID. Okay? In the next two, I am actually setting it using a set as a panel data set ID year. Okay? Now I am declaring this data to Stata that is a panel data set. It is organized by one identifier is the ID, the other is. This is how it is organized. Now Stata knows that it is panel data set. Okay, I will modify my comments, and then we run the xtreg. Okay. And then the first one is, let's say, RE, and the second one is xtreg FE. Okay, so these are the four models that we run, and you can see that how similar or different they are. So there is almost no difference between this and this. Okay. But you will come across many papers that they have a group structure, and they will say that actually I adjusted my standard errors by using this option, this one. Okay, and you can see by yourself that, okay, how much of a difference did it make. Okay, so in this one, it probably didn't make much of a difference. Obviously, there is no change in the coefficient size. Okay, even so it was not supposed to change the. It was supposed to change only the standard errors. Okay, but at the level we are looking at, because now we are looking like 0.001, so it's less than something 0.001, and we are putting a 3 star. So even if there was slight difference, as long as it was less than that, it is treating them as the same when we put a stars on that, because now we are just looking at, okay, is it less than this? If they are both of less than, if they are slightly different, it's still not treating those different. Okay, so but anyway, the beta was not going to change between this and this one, second one. The coefficient estimate is not going to change. We are only asking it to adjust the standard errors. Okay, so standard errors, when you modify that, then if the change is big, then it will show up that, okay, may 0.1 star to 2 star, or sometimes it's a little bit of a border case. It can move from slightly that. Okay, so that's what it is doing. Okay, now I'm looking. Yes, ma'am, please. Okay, but the last one is very different. Okay, so if I go by democracy, okay, so if I go by democracy, I have 4 models. 3 of the models are telling me one story, and there is one model which is telling the different story, right? And if we are Democrats, then we'll say, oh, let's go by the vote. I tested this 4 ways. 3 of them told me one story. 1 is telling me a different story. So I will go by the story the majority is telling me. Okay? But the majority is telling me is wrong. Okay? The only way we know it right now, because we are doing some cheating. Okay? The cheating we are doing is, Because we know the actual data, the relationship. What is the true value of those? Because we made this data set, okay? So because we did it, we know the true value is. Now let's look at the true value, what is there, and that's why I put those from our do file. I will put it here, okay, so that you don't lose the sight of that, okay. What is the relationship? Okay, so the relationship was set like this, okay. So we generated a variable y, and the y was generated, which has 0.21 coefficient with sales, the linear term. It had minus 0.07 coefficient with the square term of the sales, 0.26 with R&D. There was 0.08 with employees. There was an interaction between R&D and employees, and that coefficient was 0.01. Okay. There was another variable, innovation, for which the relationship was 0.3, and productivity 0.34. Okay. If I had put all those variables in the model, okay, because I just threw in some error terms, okay. So the error term was some random error components, and then there was a fixed error effect. Okay, two types of errors I threw in the building the data, generating the observations. Okay, so there was some random error on top of that, and there was some fixed effect on top of that, which was 5 times of that. Okay, so just to kind of mess up the information a little bit. Okay, otherwise it will be all perfect. Okay, so just to modify it, have some error in that, through that. Now you can see that which one is coming close. Okay, all of them are significant. If we are driven by whether we are getting significant result or not, you would see that every model is significant. The first one is significant, the second one is significant, all of them are significant. And if you go by the democracy, then also we will make the mistake, okay? Because all these are, it is a misspecified model, okay? The misspecified model, because by design, I had said, it is if there will be fixed effect is going to be significant, okay? Because I had put an error that is going to be accounted only if it is treated as a fixed effect model, and if the model has all the variables, okay? So we had in terms of the variables, so you can see if you missed anything or any of those variables, your estimates will be off, okay? And you would be able to see how much off you might be if you didn't treat the sales as a curvilinear variable, you had just a linear variable, or if you missed any of those, okay? Because in the real world, we would never know what's the true model, okay? So that cheating we cannot do, okay? Here we can see the purpose of doing this was to actually see that, okay, what is the way of thinking, okay? That it's not about the significance, that the moment you get the significant result, the story has just begun. It doesn't end with that, okay? So that's the part. That's the reason we are trying to do all this in different ways, and you can see that how different story they are telling, and we will conclude and say that, oh, I did this, and I found that as the sales increases, this goes down, okay? And I also found that it further, so, and if I just start with the first or the second, it will, okay? So there are a lot of other tests that we kind of talk about. There's a linked test that you can do to actually test for omitted variable bias and some of those. So we will be doing a little bit of some of those part of the endogeneity treatment. We talked about how to do the heteroscedasticity issues, okay? So if those are problems that you have to detect those problems and address it, and all of those are after you are done with your first set of results, okay? So you can see if you did the first one and you stop there because you got significant results, you will be running with a false story, okay? Because we know, because we did it, we made this story, okay? So we know what's the true plot here. We are setting it up, okay? As I said, we are trying to do a little bit of cheating here because we wanted to know how to sort of reach there, okay? Anytime if we don't know the true world, because obviously it will never be known to us, what's the true model, but there are steps that we need to do to make sure that we are doing enough as we can. Obviously there will be still some variables that will be left out, okay? Because we will not be building like 100 variable models, okay? And it is possible there are 100 predictors of that whatever we are studying. And so there will be always an omitted variable situation there. There is something that's still not there, okay? And you have been augmenting, a lot of people have done, so you are adding that. Okay? Many times people do all kinds of cheating, okay? So I have come across some people doing survey work, for example. So they collected one survey, big survey. Now that survey has, like, let's say 10 variables that they have gathered the information. And in one paper, they made one variable a dependent variable. In another paper, there is the same variable is also a dependent variable. But in paper 1, there are 4 of those variables out of possible like 7. They show up. 2 of them are maybe significant. And then there is a paper 2 coming, which makes no reference to the paper 1, in which they themselves actually found that these are the variables which I have found that they are significant. Okay? So we are supposed to include those in our paper 2, okay? Because we know that if we do our own literature, let's say if somebody else has done it, okay? So the expectation will be, if you are reviewing that paper, you'll say, oh, why don't you look at this paper, because they have looked at the same dependent variable. Here are these things they have found significant. You should control for that. Okay? That would be the natural thing you will be asking. Why in the world you are not doing it? Okay? Because if I do that, my paper 2 will not exist, because those variables will not be any more significant, and I need to make them significant. So that you understand the story. Okay? And so I also, and this is one reason I serve on the university ethics committee. Okay? A lot of people are really scared because they know that I come hard at these kind of issues, because we can't do it. Okay? There is absolutely no way we can let people just do these sort of things that has been going on all around the world. Okay? It's not about any particular part or any particular institute. It's a global thing, and it has been going on. So I mean, we should try to do the best we can. We can't root out the problem entirely, but you understand, okay? So the omitted variable problem is already there. So if I have found something, we should include that. Just will mitigate that omitted variable problem, because you already know that there are, and if it is coming from the same data set, it's absolutely criminal to actually not do it. Okay? Because at one point in time, there will be somebody will be able to put those studies together, like I did for one person, okay? And I said, okay, I see this is coming from the same data set, because it's the same study, same sample. Why can these 2 papers coexist? Tell me that, okay? Can these 2 papers coexist, simultaneously exist? And the answer was no. So, and those things, once it goes to that level, it's a huge crisis, because it's obviously you lose the respect. That's probably you don't care about it. I mean, you means like the person doesn't care about that. Okay, if they care about that, probably they would not have been doing it. So the respect probably doesn't matter to them. They would lose right away. But you think about the career implications of these kind of things. So it's very important for us to guide the people to actually make the right kind of choices. That, okay, you already found that, okay, you have to make it so that you don't lose face and somebody tells you that, sir, I see this is the paper you published maybe a year before, and there's another paper you published, and that you may be the supervisor. Okay, think about the situation, and your student comes to you, okay, saying that, sir, you actually published these papers, and I'm trying to sort of reproduce the results, and I'm not able to actually do it. Can you give me your data? Okay. Maybe you will tell, oh, I lost, I don't know how many years ago I did it, I don't have the data. Okay. People go back. Papers have been retracted 10 years, 20 years, 30 years. They have published 30 years ago. But now people are detecting it, because there are some people who have fun with this kind of activity, okay? So they like it. We can look at your correlation table, okay? And try to reproduce your results. You have reported that correlation table, okay? So you cannot say that it's false, okay? And many times we are not able to reproduce the result from your reported correlation table that you have reported in the same paper, because we are using the same aggregate information and trying to reproduce using the variables that you have used, and we are not able to get anywhere close to results, okay? Because what you did was, okay, I needed 2 stars here and change the coefficient here, so I made it 0.02. Looks like that's a good enough number, because like random stuff you're doing, okay? And it will show up in there. So it's very important that, like sometimes you think, oh, why I'm emphasizing these things, okay? Because they are the most important things in the choices that you are making, okay? If you go wrong in doing this, there is no problem. You can say that, okay, I did this test and I didn't do the other ones, so that's why I got the wrong answer, and there is nothing I did which I should be ashamed of. Maybe I should have tested for the other ones, but if you test what I did, you will still get the same result, okay? And there is no problem in that, okay? We learn, we move improvement. That's what the society, that's why there are so many people working in that area, that there is something you didn't do it, somebody else will kind of say, okay, here's one something, maybe if we try to do differently, run a different model, maybe we'll get a different result, okay? And there is absolutely no problem in that, okay? The problem happens when I try or you try to do the same thing somebody else has done using the same data set. Forget about a context difference and this and that, okay? We're using the same data set, sometimes using your own data set, and still can get the results that you have reported. And that's a huge issue. It's a huge issue. So we have to be sort of cognizant of this kind of problems, okay? So, and I had a colleague, okay? She made an honest mistake. There are mistakes people do, okay? And the mistake she did was, it was published in a top journal, that paper, and according to her, she copy-pasted the coefficients from an Excel file on the Word document she had. So obviously when you are copying, pasting, so it's sometimes possible that you copy it from one column and you paste it in the wrong column, okay? It's possible, maybe that's what happened. It was still a huge embarrassment for her because publishing in a top, I mean, it's a lifelong, like everybody knows about that, okay? Oh, she was the one who did it, okay? And obviously it's a long explanation that it's a copy paste mistake. So one thing, there are some mistakes we can avoid, okay? Never produce result using copy paste, okay? You can see on the screen, but never do copy paste, never, okay? Import the data, the table, generate it, import it in an Excel format or export in a Word file, whatever, okay? And then reproduce the entire table, okay? So that there is no way you can make that kind of copy paste mistake, okay? Like one time Sonia Gandhi did when she claimed her qualification that she had a long degree from Cambridge University, and when people questioned that, so her answer was that it was a typo. So the response was that probably this is the longest typo in the world, okay? Because it had a huge name, okay? Like going, like degree just keeps going on and on and on, and until Cambridge University, and none of that was actually true, okay? Neither the front part nor the back part, okay? And the difference was it was a typo, okay? So you don't want to make that kind of longest typo in the world and that kind of mistake, okay? Let's take a maybe 15 minutes break here, okay? And then we'll do some of the rest stuff, the stuff that we have to push today, okay? Thank you.